Alright everyone, I want to talk about glycolysis. We've heard about glycolysis earlier this semester. Do you guys remember where? In chapter 19 with the red blood cells. Glycolysis was all they were able to do because they didn't have a mitochondria. Alright, so what is glucose? Glucose is a 6-carbon molecule. They're not arranged linearly like this, but to keep it simple, I decided to draw it that way. And so what we're going to do is we're going to start with the 6-carbon glucose. We're going to have two different phases. We're going to have the energy investment phase and the energy payoff phase. And in the energy investment phase, we're going to have to put in ATP in. It's kind of like that phrase. Have you ever heard the phrase, it takes money to make money? Well, in this case, it takes ATP to make ATP. And here's the part where it takes ATP. We're going to put 2 ATP in. And at the end of the energy investment phase, we're going to have glyceraldehyde 3-phosphate. 3 carbons and a phosphate, right, on either side. So from each molecule of glucose, I have 2 of these, glyceraldehyde 3-phosphate. Now these continue on in the energy payoff phase. And for each one of those, we make 2 ATPs, and we get 1 NADH, which if you remember from earlier, here's another NADH, one on each side. If you remember from earlier, those are electron carriers. So those get reduced, and we'll talk next lecture about where they're going. Alright, so what do we end with? What is the final product of glycolysis? We get pyruvate, and we end up with 2 pyruvates. Alright, so we start with glucose. At the end of the energy investment phase, we get glyceraldehyde 3-phosphate. And at the complete end of glycolysis, we end up with 2 pyruvates. Now, what happens with pyruvate? That's not ATP. Well, before we continue on, so there's a mid-step here, and it depends on whether there's oxygen available or not. So if there's no oxygen available, it's said to be anaerobic. Have you ever done aerobics? You breathe heavier, right? Aerobics meaning with oxygen. I've never done anaerobics, and I'm sure none of us have, to exercise without oxygen. But we have all heard of lactate and lactic acid, and we've all felt that, right? So if it's anaerobic, it gets converted into lactate. If it's aerobic, then it gets converted into acetyl-CoA, and you get another NADH, an electron carrier. Does that make sense? So without oxygen, you get lactate. With oxygen, you get acetyl-CoA. It gets converted to acetyl-CoA, I should say, and you make an NADH in the process. I should say you reduce an NAD to NADH. So what do we have total here? For glycolysis, you had 2 ATP in, 4 ATP out, because 2 from each side in the payoff phase, 2 NADH out, and 2 pyruvates. The pyruvates then can take one of these 2 pathways, depending on whether or not there's oxygen available. Does that make sense? So our net is 2 ATP for each glucose molecule. Not a lot, not a lot. So I also want to talk about what type of reactions we saw here. We had anabolic reactions. Here we go. We took the 2 ATPs and we added a phosphate to each of these, anabolic. We had catabolic. We broke down the ATP, and we also broke the glucose in half. We also had oxidation reduction. NAD was reduced to become NAD plus was reduced to become NADH. Here, 3 times here. So 3 of the types of reactions that we talked about earlier, we're now seeing here in glycolysis. Alright, starting with the 6 carbons, 2 ATP in the energy investment, and we end up with glyceraldehyde 3-phosphate at the end of the energy investment phase. Each of those continues on, and you produce 2 ATPs, 1 NADH each, and it ends up with 2 pyruvates, which can then continue on to lactate if there's no oxygen, or acetyl-CoA if there is oxygen. With the latter, you produce an NADH. Well, I hope that makes sense. Let me know if it doesn't. Okay, goodbye everyone.